Hello everyone, this will be Module 1, Lesson 2, and this is all about proportional relationships. In the last video, we learned about ratios and how to find a rate from a ratio. Now we're going to find out what if the relationship is proportional. Hopefully this video will be a little bit shorter compared to some of the others. So our first slide is going to be your vocabulary. You only have one vocabulary word that you need to write down here, and it is a proportional relationship. That is a relationship between two equal ratios. I might also need you to write this bottom part down that says it is represented as y equals kx, where k is a constant unit rate. So this is your first example, and we're trying to figure out, is the cost proportional to the ounces of frozen yogurt? So the chart below shows us frozen yogurt prices. It shows different weights and what their cost is going to be. So what we're trying to figure out is this table made up of equal ratios? So to figure this out, we need to set up our ratios. So our first one, we have, let's just go, I'm going to add some numbers to this. We're going to call this person 1, person 2, person 3, and person 4. And if you would, just go ahead, pause the video, copy down this table for me, so we can get to work on finding out if this is a proportional relationship. So let's talk about person number 1. We are trying to figure out, is the cost proportional to the ounces? So as we're writing that ratio, which number do you think should go first, the cost or the ounces? I hope you said cost, because we want to know if cost is proportional to ounces. We should write it as the cost, which for person number 1, this is 5, to our ounces, which is 12.5. And hopefully you remember from our last video, whenever you are trying to find a rate from a ratio, remember we divide the first number, so in this case it's 5, by the second number, which is 12.5. And remember, I told you we will have calculators for this, so I'm not expecting you to know this off your head. But if you do 5 divided by 12.5, it will give you 0.40. So if we know it's 0.40, what does that tell us? It tells us, essentially this is saying it is 0.40 dollar per ounce, but another way that you guys would probably see that written would be 40 cents. Whoops, let me fix that. I did not write that correctly. It's going to be 40 cents per ounce. All right, so that's the rate of of person number 1. So let's look at person 2. Remember, they're at the same frozen yogurt store. They're all together. So this person number 2, they paid $4 to our 10 ounces of frozen yogurt. So we want to figure out that rate. So we do 4 divided by 10. And what does that equal? This one also equals 0.40. So it's the same thing. It's going to be 40 cents per ounce. Let's look at person number 3. Okay, so we're again going to compare the cost to the weight, which is 5. 2 to 5. If we want to figure out the rate of that, we divide it. So 2 divided by 5, which, as you could probably guess by now, is going to give us 0.40. Is that the same? Yes, that also means 40 cents per ounce. Last one, we have person number 4. I'm kind of running out of room here, but I'll try to make it fit. We have a cost of $3.20 to our 8 ounces. So if we divide 3.2 by 8, we will find the same answer, which is 0.40, which again we can write as 40 cents per ounce. So do you guys think the cost is proportional for proportional to the ounces of frozen yogurt? The answer is yes. Because they all have an equal ratio. What we just found out, whoops, that was not on purpose. What we just found out is that all of these have the same rate. All of our examples, 1, 2, 3, and 4, they all have a rate of 40 cents per ounce, which means that because we have equal ratios, we have a proportional relationship. So remember how I told you that we can represent that as y equals kx? I'm going to move up here to the top. You can look up here. I told you that a proportional relationship we can represent as y equals kx. And who remembers which one was a unit rate? Which letter represents the unit rate? I hope you guys said K, because K represents our unit rate. So if I were to write an equation to represent this proportional relationship, all I would do is represent that K with our unit rate down here, which is 0.40. So we could say, for this frozen yogurt, y equals 0.40x, where the 0.40 is our unit rate. It's the price per ounce of frozen yogurt. I know that this might feel a little confusing, but essentially all that we did was said, if I divide the cost by my ounces, that's going to give me this increase right here of times 0.40. Okay? For all of these, they are equivalent. We are multiplying by the same thing every time. Remember with flipped classroom videos, if you ever have questions, that's okay. I don't expect you to understand everything. That's what we're going to talk about in class tomorrow to clear up any questions. But I do want you to go ahead and try this problem. Even if the last example didn't make a ton of sense, I really think you guys can figure this one out. I want to figure out is the number of calories burned. Is the number of calories burned proportional to time? So as you are writing all of your, as you're writing your ratios, the calories burned will go first, then the dots to represent the ratio, then the seconds. I'm just going to get you started. So for the first example, if I'm trying to figure out if it's proportional, I would do 10 calories burned to 1 second. Then I would divide to find out that rate. So go ahead and pause the video and try this one out for me. Okay, I tried to give you a little bit easier numbers to work on in case you don't have a calculator at home. But let's start with this first one. I already set the ratio up for you, 10 to 1. So remember, to find the rate from a ratio, you divide the first number by the second number. And what does 10 divided by 1 equal? 10. So this shows that you're burning 10 calories per second. Let's look at our second time that we have. So after 2 seconds, we're burning 20 calories. So to write that ratio, we do 20 to 2. So to find the rate, we do 20 divided by 2, which also equals 10, which means that our rate is still 10 calories per second. Fix that and make it a little bit neater for you. Let's look at number 3. I'll write it down here so I don't run out of room. Again, we're going to write our calories burned to our seconds. So in order to find the rate, we're going to do 30 divided by 3, which, just like the other two, gives us 10. And let's go back to this very last one. We're going to write our ratio, which would be 40 calories to 4 seconds. If we divide 40 by 4, it still gives us 10. So all of these, as we can see, it all has a rate of 10. So 10 calories per second. So if I were to write that equation, it would be, I'm going to come back up here to the top. So remember, we use the form y equals kx. And we know our unit rate for this one is 10. So we have y equals 10x. I do know that this lesson is just a little bit tricky to grasp through a video. So come tomorrow to class or Friday to class prepared to ask me any questions you may have. We will go over one more example together as a class before you get started. So have a great rest of your night, and I look forward to seeing you tomorrow.